Questions about the number of solutions for quadratics are kind of annoying. There's a couple of ways to do them, and it really does depend on what they're asking, but I'm going to show you the way that's going to get you the answer in most cases, because in this case they want exactly one point of intersection, which is honestly usually the easiest situation. That's the one that lets us be most flexible about different options. We could use the vertex to help us solve this, but instead I'm going to use the discriminant, which is something that should work whether they ask for one solution, multiple solutions, or no solution. So it does involve the same process each time. Basically, we're going to use the idea that the discriminant, which is part of the quadratic formula, that is b squared minus 4ac. And depending on the number of solutions, that quantity is going to equal different things. So in this case, since we want it to have exactly one point of intersection, we want this to be 0. But we can only use this if we have one equation. We don't have that here, we have two. And so what we need to do to start this off is we need to combine these into one quadratic equation in order to be able to plug it into our discriminant formula. So the first step to doing that is to, let's make this y, 2y equals 64 something more simple, right? If we divide by 2 on both sides, we're going to get that y is equal to 32, which we can then substitute into the second equation. And so now we would have 32 is equal to negative 1/2 x squared plus bx, but it's still not in standard form. I need to move the 32 to the other side. So when we do that, we get 0 is equal to negative 1/2 x squared plus bx minus 32. And now we have our a, b, and c, which we can plug into the discriminant and set it equal to 0 and see what happens. Okay, so let's do that. In this case, b is going to be b, so we'll just leave it as b. That's what we're solving for. Minus 4, well, a is negative 1/2, and c is negative 32. And like I said, if we want this system to have exactly one point of intersection, one solution, it's going to be equal to 0. This is just what happens with the discriminant when we have one solution. So we now need to solve for b. So we have b squared. All these negatives are going to result in just a regular old negative. So 4 times 1/2 is 2. 2 times 32 is 64. So b squared minus 64 is equal to 0. Move the 64 over. We get b squared is 64. Take the square root of both sides, and we are going to get that b is equal to 8, and that is the answer. So to me, this is the best way to handle something like this, because in case they had asked for situations where there's multiple solutions, 2 solutions, or 0 solutions, the discriminant kind of covers all of these contingencies. Whereas it's really, if we wanted to use the vertex, which is another possibility, that's really only going to be effective when we have one solution that we care about. So it really does depend with quadratics on what they're asking for, because quadratics are more complex and there's more possibilities. But the discriminant is going to cover those possibilities in the easiest way possible, though I do admit this is not an easy topic.